During the 1700s, fine art painters formalised the concept that three primary colours were red, yellow and blue, and that by mixing three colours in different proportions, all other colours could be obtained. They produced a colour to show the results of mixing the primary colours to produce the secondary colours: orange, red and yellow, green, yellow and blue, and purple, blue and red. By mixing all three primary colours, a very dark colour, either brown or grey, is achieved. People in the printing industries, magazines, newspapers, etc. use magenta, very much like purple, cyan, a lighter greeny blue, and yellow as their prime colours, to which they add black. Many computer printers use these colours to produce pictures. If you look very closely at a picture or a photograph in a magazine, you may be able to see the individual dots of ink that make up the whole effect. When using these coloured inks, printers argue that it is possible to produce a wider range of colours. They will make red from mixing yellow and magenta, blue from mixing magenta and cyan, and green from mixing cyan and yellow. Black is made from a mixture of all three colours: magenta, cyan and yellow. Both of these sets of colours are called the negative prime colours because they are taken away from the white light reflected from the paper. Scientists have always used the positive primary colours: red, green and blue. This is because they start with black, a complete lack of any light, and add colour to it. The easiest way to see this effect is to look very closely at a television screen. You will be able to see the way that the dots of light add to the black background to produce the required colour. In 1981, the first popular programmable colour computer, called the Sinclair Spectrum, was launched by Clive Sinclair. This was the first time that numbers had been allocated to colours. The Spectrum used 0 for black, 1 for blue, 2 for red and 4 for green, but adding blue and red makes magenta number 3. Blue and green makes cyan number 5. Adding red and green makes yellow number 6. And adding all three colours makes white number 7. By replacing the B, R and G with 1s, 2s and 4s, you can now see that the numbers now represent binary numbers. This use of binary numbers, of course, perfectly suited the computer industry. On that thought, back to the studio.